Yeah, hello everyone. Today's session is around ISO 21434, which is the cybersecurity standards for automotive. And in today's session, we will see how Codebeamer can help organizations to adopt ISO 21434 in their product development process so that they can develop safe and secure systems. Now, before I get onto the agenda, one quick thing I wanted to just highlight the need for the ISO 21434. Therefore, as you see in the backdrop in this picture, like as and when the more and more vehicles they get added to internet, uh, they also get exposed to the online threats. Now, today, as of today, like suppose right now, all of our laptops are connected to internet, or even our mobile phones are connected to internet. So we all are exposed to this online threats. But when it comes to vehicles, it is much more critical because it can also lead to extreme damages and fatals and as well, and so on. So that's why it is important that there is a standard and there is a regulation and all companies they adhere to a standard. Now, ISO 21434 uh, it defines the requirements for security processes, and it also defines a common language for understanding software security and the cybersecurity risk management. And with this, it helps to eliminate the need for individual approaches by the company, and it provides a very common framework to tackle the cybersecurity for automotive production. And we will see like how this standard is templatized in Codebeamer, and that makes life much easy because once if you start using the templates in Codebeamer, you automatically start adhering to the processes defined by this standard. This is the agenda for today. Therefore, we will just touch upon the industry-specific template. We'll focus only on automotive and only on this template. And then the other thing is this, that Codebeamer is a complete ALM tool, and it will not be justice to it if I don't mention this, because what I'm going to cover is only the cybersecurity aspect, or only the trackers which are meant for the cybersecurity. But Codebeamer offers a lot. Codebeamer is a complete ALM tool, and when you do a project, this is only one piece of it, and then eventually the bigger piece is all here. But we will not cover about requirements management, spec management, or QA and test management and release management in this session. Already videos in our YouTube and on our PDSVISION website. The same thing is for the non-application aspect. All these are part of the trackers management, and we will not cover all this. We will just focus on the cybersecurity. Also wanted to highlight that while we talk about the cybersecurity, it also requires a lot of traceability to be taken care of, and we will definitely touch on the traceability and traceability browser in today's session. Now, what you see here, this is the cybersecurity process, or I would say like the 2134 structure. Now, what you see on the top, let's go from the top. What you see on the top, this whole area is the organizational, or I would say the governance level. It defines the organizational cybersecurity management, and this is typically the governance level, like how the cybersecurity should be enforced, how to assign responsibilities, how should the communication be structured, how are the processes defined and improved, and so on in the organization. So this is something which we are not going to cover. This is too broad, and I don't think it's done at the ALM level. The second level is on the second level is at the project dependent cybersecurity management. This is more at the concept and the development level, like how to plan cybersecurity, how to assess cyber achievement, how to prove cyber achievement, and what is an acceptable cyber achievement, and such type of things. So this is more at the concept and development level. Then the next is at more, I would say, at the ecosystem level. And this is where you it's more around the supplier and the automotive OEM. That is like how to organize cybersecurity between different parties, that is suppliers and the OEMs, or how to select suppliers, or how to share responsibilities, and so on. Again, this also will not be covering, therefore not the organization level or the governance level, not the project level, not the concept and development level, and not at this level. The next one is at the risk management level, and this is important, and this is where the data piece of it. And this whole thing is implemented in Codebeamer and is part of the template itself. That is from the risk identification, the threat scenario, impact rating, the attack path analysis, the attack feasibility rating, the risk determination, and the risk treatment. Therefore, this will be definitely part of our today's session, and this is what is the core part of the cybersecurity, or data we call it, which we'll see now. Then is now this is the more on the development side. Therefore, we will also touch upon this because this is the concept phase where we do this, and then is the product development. We'll not cover the product development, but we'll just touch base on the slide, but not on the demo perspective. Therefore, white Codebeamer and the industry specific template, we will use the automotive template. Automotive template comes with all the three, and our focus would be more on this. So therefore, the project which I will use for today's demo is a front light management ECU. And we will focus on this, and that project is created using automotive template, and which has got all these three elements. Now, how Codebeamer can help in compliance adherence with ISO 2134, and it is through this data model. Therefore, just now we talked about item definition. We also talked about asset identification. We talked about damage scenarios, or I would say that impact rating, and the threat scenarios, the active attack path stuff, right? All, if I go back, all of these, this is the block which I talked about. So therefore, it starts with the asset identification, then threat scenario, impact rating, attack path analysis, attack feasibility rating, and so on. And this picture which I have taken here, it is from Codebeamer itself. Therefore, therefore it is from Codebeamer. And our focus will be still, only up to the data, because from there we can define the cybersecurity goals, we can define the cybersecurity concepts, and then from there we can start using it for our product development. So therefore, the whole session will be around this area. Okay. Now with this, I've further expanded this, but I will go to the system and then probably show you and then get deeper into it. Therefore, I have logged into the system. I'm not creating a project, but when you create a project, you select automotive template and you get the 21434 as inbuilt as part of the template. Now, once I log in and once I click into this project is an existing project, and it is about this front light management system, management ECU. Now, this I am now into item definition, but before I get there, if you have not seen the earlier video, just let me give me a very quick brief about what I am doing and how the Codebeamer is organized. I have already a project, therefore I logged into the system. I went into an existing project. Once you have created a project, once you get into the project, everything is organized as in trackers. Therefore, each of these line items, they are like, we call it as a tracker. They are like a container. Okay. And like, for example, all the item definitions will be in this, all the HADA will be here. Same way, when it comes to cybersecurity, all the tasks will be managed under this. All the assets will be managed here and so on. Whenever you want to go into it, and each one of it has its own life cycle, own attributes, own permissions, own notifications, and so on. Now, when you double click, you get into it. Therefore, now I'm into item definition. And as we saw in our here, 1 minute. if I go in this tab, therefore it all starts with the item definition. Now, item definition is a high-level scope definition of the system under development. It could be a system, or it could be a system of system. And in nutshell, basically, it is um, it is our target of evaluation, like whatever we are going to evaluate that particular system. Now, in this case, it's frontline management system. Therefore, yeah, this is the one. Now, if I go here, now in this, you have a frontline management system and you have all these items here. Now, apart from it, you can also have items associated to functions. Like, for example, if I go to light switch, and if I scroll here, I can see there are some functions connected to it. Therefore, I don't need to define all the things in this small window here, but I can also associate other tracker, which gives us some more details. Now, again, if you have not seen the previous window, a quick explanation of this layout. What you see on the left hand side is the tracker and all the tracker work items. Like in case of item definition, all the item definitions here. Now in the middle, you have the details, and on the right hand side, you have attributes. If I select anything on the right hand side, you have attributes. Then you have references and you have associations. The middle one is for the release, and the last one is for reusability. If I want to reuse from any project into this, I can just drag and drop. OK. Now we talked about item, that is, in this case, a frontline management system. Now, when you get into with respect to 21434, the very first step in the process is that you go ahead and do an identification of your asset. Now, when I say asset identification, what do we mean here? See, the whole aim is of this whole cybersecurity is to protect the item, okay, which is my frontline management system. But an asset belongs to the frontline management system. Asset belongs to the item. But we need to identify the asset within the item and protect them from the hackers or the attackers. Like in this case, in the frontline, in the case of frontline management system, an asset could be the light itself, or could be the oncoming car information. Like, for example, if I'm driving a car like this, and there's another car coming from this direction, we have a sensor which also senses which car is coming from this direction and the distance, and then it puts into the low beam. Now this ongoing car information, if a hacker can get this, they can manipulate and they can put my car on a low beam. So therefore, the asset is something which we want to protect, and the asset always is within the item. So that is, we need to identify all the assets which we want to protect from the hacker or from the attacker. So that is the second step in this process. Therefore, if I go here, we define item, and then we define the functions which defines the item, and then we go ahead and define assets. So therefore, if I go to assets, and if you see here, the asset what asset we have identified is data communication and a LAMP request, or data communication ongoing car information. As I said, and if the hacker can get the ongoing cars information, or if they can simulate, they can create a big damage. Okay, by playing around with the low beam and high beam of our car, right? So that is the asset which you want to protect now, or the information which you want to protect. Now, an asset, if I go to this attributes tab, let me expand this. So therefore, there's nothing much in the asset, and then it has a reference to the item. It should have a reference to the item. It is not connected here, but I can always add an item here to which it should refer to. Therefore, asset is within an item. Okay. Now we go to the next part of it, which is the damage scenarios. Now, in case of damage scenarios, there's two things. If you see here, there's a branching which is happening here. Therefore, item definition, asset, and then it goes to the damage scenarios, and then to the data. And then it also has asset, and then it goes to the threat scenario, and from threat scenario, attack path, and then to data. Now, what are these two paths here? See, what we do is Once we know that what we need to protect, or what we have identified which we need to protect, this there could be there could be what do I say, like a default damage scenario. That means it may not work, and if it doesn't work, there is a risk. The other could be there's an external attacker or hacker who is not who is creating a malfunction externally, and that is a threat which we see. So that this is threat is something which which let me define in this way, like a damage scenario is the undesired result due to the compromise in the security properties of the asset itself. That means every asset which you have, they have some security properties like confidentiality. We call it as a CIA. That is confidentiality, integrity, and availability. Now, whenever there's any compromise on any one of it, that is confidentiality, integrity, and availability, it will lead to an undesired result because of this compromise, and that is what is the damage scenario. Okay, but the damage has happened. Okay, that's what I meant to say earlier. And for this damage, you do the estimation of this damage in the following categories, like safety, finance. Like what is the damage from safety perspective, from finance perspective, from operation, and from privacy perspective. And this we call it as an impact rating. That is the impact rating of the damage which will happen. Okay, if there's any compromise the in the cybersecurity properties, the CIA. The other one, the threat one, this is the statement of potential negative actions that can lead to the damage scenarios. There's a potential that something can be hacked and can lead to a damage scenario. Therefore, and this leads this is further defined by attack path analysis and attack path feasibility rating. So what happens in this case is, in this path is, like once you have identified the threat, then for that threat, then you do the attack path analysis. You try to figure out how some hacker will try to do it. It is like a set of actions that could lead to the realization of the threat situation. And then based you identify all the paths, like what the hackers can do, and then for each one you do a attack feasibility rating. That is, you think from what expertise the hacker should have, what knowledge the hacker should have, and based on that, you do a attack feasibility rating. Now, what is happening now is, see, one is the damage scenario, the other is the possible threats and the way the attack the hacker can attack it. With these 2 points, you do your risk assessment. That is data. That means you have the impact rating from your damage scenarios, and you have this attack feasibility rating from this part, that is from threat analysis. And these two together, when you analyze from the risk assessment, and then you determine what is the risk, and then you determine define what is the decision which you want to make for that risk. Like do you want to accept that risk, or do you want to transfer that risk, or do you want to avoid that risk, or what is the decision which you want to make around the risk. So this is the overall the concept behind this, and this is how it is also modeled in the Codebeamer. So we saw the asset. Now let's go to the damage scenario, then it will be much clearer. Therefore, in the damage scenario, again, it is open in a tabular view, but we can change, like whenever you have anything which is like a lot of scenarios with a lot of columns, then typically the default view is configured as table view. But you can also click this document view so that you see the same information, but in a little bit different way in the 3-panel view. Now, here what is happening is, now these are damage scenarios. What I meant is here, this one, the damage scenario, okay, where somebody is coming with a full light and it's glaring on my eyes, and the damage has happened. Okay, and means my low beam did not work. Okay, now in this case, what you do is you you define this the attributes. Therefore, you look at from the three cybersecurity properties of the asset. Is the confidentiality compromised? Did the integrity of that asset compromised, or availability of the asset got compromised? So therefore, based on that, you decide, like, you just populate this. Like, for example, confidentiality, did it compromise or not? Now, whenever you have any one of them compromised, that means there is a impact rating for sure. Okay. And then you have this other three part. This is where you do the impact rating. Therefore, you also do the estimation of the damage in the following categories, like, from safety perspective, what is the impact, from financial perspective, what is the impact, and so on. And these are typically negligible, moderate, major, and severe. Therefore, with these ratings, like, like what got compromised on the cybersecurity properties perspective, and what is the this estimation of the damage from impact perspective. So therefore, you decide for each of these damage scenarios. Okay. Therefore, this is all collected, and this is all as per the ISO 21434, and all damage scenarios are connected to asset which you see here. Okay. Now, after the damage scenario is all done, then you can decide a threat scenario from a damage, or also from an asset also. They need not be that every threat could be derived from damage scenario. You can also have threats which are not derived from a damage scenario. Now, what could be a threat? Now, if I show you the example, it is much easier to understand. But as I said, um, damage is the undesired result due to the compromise on the security property, right? But threat is a potential negative actions that can lead to the damage scenarios. So therefore, let's go to the threat scenarios. Now, again, let's go to the document view. Now, what you see here is that like, denial of service of oncoming car information. Now, for some reason, there is a denial of service of oncoming car information. I'm not able to get the oncoming car information, right? So if I'm not able to get that, because I'm also hacked, for example, right? How my car is going to behave. Probably my car may not behave the way it is intended to behave now, right? And these are all known as threat scenarios. Therefore, for each threat scenario, if I look at this, therefore there is a damage scenario. That means this is derived from this damage scenario. That is malfunction. You have to move your mouse here. You'll get the full thing. Malfunctioning automatic high beam caused by headlamp always remaining at low beam during the night driving, and so on. So basically, you analyze this damage scenario, and then you think about what could be a threat scenario, and then you define the threat scenario here. Now, and this can also be independent. Like, for example, in this case, all are connected to damage scenario, but you can also have a threat scenario which can be independent of damage scenarios. Now, once you have defined the threat scenario, then you do the action path analysis. Now, the action path analysis has got two parts. One is the path analysis itself, and the second part is about the feasibility. So therefore, in the action path analysis, let me just go here and then show you. Like, once you go to the attack path. Therefore, when you look at these here, you will see these fields which are known as attack feasibility rating. And what you do in the attack path analysis is it is a set of actions that could lead to the realization of a threat scenario. Like, what all has to be done to make this attack possible. Okay, so that is how you analyze this. Okay, and then the feasibility rating is like, the specialist expertise, like what expertise is required to create this attack. What is the window of opportunity? What is the equipment? What is the knowledge required? What is the elapsed time, and so on. So therefore, with all this, once you fill up all this, you get a attack feasibility rating. This attack feasibility rating and the impact rating from the damage threats, from the damage scenarios, both input goes to Tara to figure out, what is the risk value. Like, or in this case, I guess if I change this, like suppose in this case, if I make this more, and suppose you can see this keeps changing now. So therefore, suppose if I say specialist, this is suppose 7. See, you see here the attack feasibility value keeps changing, and the rating will also change. It depends upon what permutation combination I apply here. So the whole point what I wanted to highlight was this, that this whole framework is inbuilt into the template with all these calculations, and I don't think you need to do much. Even if you want to do, it's very easy to tailor. You can just click here, configure, and enable it. But this is what you do in the attack path. Okay. Now let us go back and see what is there next. So therefore, as I said, like if you go back to this diagram, so we talked about item definition, we talked about asset identification, we talked about damage scenarios, and then we also talked about threat scenarios and the attack path. And then finally, all this gets connected to Tara, and this is where you get two inputs, one from this side and the one from the threat side, which is the same like this and this, which is the attack feasibility rating, and then one is from the damage scenario directly, which is the impact rating. And then let's look at Tara. If I go back here and look at Tara, now I have only one item in Tara, but if I go in this, so now if you see like headlamp cellular interface spoofing. Now for this spoofing, if you see this whole path now, like you have an asset which was identified, which was the lamp request, and the damage scenario was, again, I have to move my mouse to see the full context here, but there's a damage scenario, and there's a safety impact because of this, and then there's a threat scenario, and there's a threat scenario, there's an attack path, and because of this attack path analysis and all, feasibility rating, and the rating was very low. And now what is the risk? What is the risk treatment option? Now in this case, it is reduced, but you can have avoidance. You can say I can avoid the risk, or you can reduce the risk, or you can transfer it to the other unit like other ECU, or you can accept the risk. So these are the options which you have for your risk treatment decisions. Okay, and with this is what you do to define a Tara, and then once you have done this, the easier and better and easier way to see this whole thing is to go to your traceability browser. Therefore, I'm now going to the traceability report. You can invoke this traceability report from any of these trackers. Now, either I can go and create a new traceability report where I can say that, OK, I want to start from this, and I want to start from Tara, or I want to start from item. You can choose either way, or you can start from asset. It depends upon how you want to do it, but you can also start from asset and so on. And then I can define level 1, then I can define level 2, and then I can define level 3. Once everything is done, I can hit go. This is one way to do it, but since I've already done it, I'll just click my report. OK, and sorry, I'll say find reports, and I have already saved a full filter here. Let me open that and show you. Therefore, I opened it, and it looks like this. Like you cannot see the query which is put here, but I can show you from here. Like if I go and click edit, what I did is to understand this concept best and this whole model from here to here, from item definition to Tara. It's much easy to see this and understand. Like you have an item definition on the start. Then from there you do the asset identification within the item which you want to protect, and then you look at all the damage scenarios for this asset. OK, like which is possible, and then based on that you define. You also try to derive all the threat scenarios from, like, just think from a hacker perspective, right? This like what are could be possible options. And then think about all the paths which the hacker can take to do this. and all then finally leads to Tara. Therefore, in item definition, I put item ID and summary. In asset, just an asset, but in damage scenario, it is about CIA. That is, what is the compromise between C, I, and A. This is very important, which is what is the which one has been compromised on the asset. Like is the confidentiality compromised, or is the data integrity, or is the availability itself? And then you also look from the impact perspective, like this is more from the safety, privacy, and operational and finance impact. What is the impact because of this damage? Then this is more from the threat scenario, more from the hacker perspective. Therefore, you identify all the threat scenarios, and then for each of the threat scenarios, you have to do the attack path analysis and attack path feasibility rating. So therefore, as part of the attack path analysis or the feasibility rating, what you do is you look at elapsed time, you look at equipments, you look at what is the knowledge required for the item, you look at expertise required for it, look at the window of opportunity, and then you get this attack feasibility value and the rating. So this is all gets derived once you have this information. And then when it comes to Tara, you will use this attack feasibility rating, and then you will also use the safety impact. With these two together, you will determine what is your risk value and what should be your risk treatment options. This, and then when I run this report, you can collapse this. Once you run this, you get it something like this, like the ID, the summary, and then you get the damage scenario, and then here you get the CIA. I actually rearranged it. That if I hit the go, it will be much easier. If I hit the go, I'll get the fresh report where I have just rearranged CIA. Therefore, in this order, CIA. So it's easy to read, and then you can see the safety impact, and then is the threat scenario, and then is the active path and active path, and then this is the active path feasibility rating, and then you get the data here. Now, once we have this data, this is the place where now what you will do is we can define the safety, cybersecurity goals, and then the goals into concepts, and then we can start using it for into our system development, or product development. This is how it happens. And if I go to the next slide, this is after that, we just get into this, and then we do the development, and then we deliver. But your cybersecurity concepts are also embedded into each of these layers. But what we discussed was more on the concept phase before we hand over to the product development, and that is where Tara was the core part of it. That's what I wanted to talk about in this session, and thanks.